Here with Wes and Andy. You guys are from Stark State College of Technology. That's in Ohio. Whereabouts in Ohio is your school located?
It's in North Canton, Ohio, south of Akron.
South of Akron. Okay, and you got this pretty complex looking device behind us here. What is this?
This is our fuel cell test stand. It's actually under the Department of Energy grant for balance of plant fuel cell test stand. We're partnered with Lockheed and Martin. They're our subcontractor. They're helping us determine what different components we're going to be using in the test stand itself. And what this is going to allow us to do is test all the different components that are in a test stand for life of the component, for durability, and for function as well.
Could you explain a little bit the major components of this thing right here?
Major components, we have a Parker pump down here for circulating the hydrogen. It's a univane.
The Parker pump is the
large unit right back
okay,
here.
that right there. Okay. And what does that do?
That's what circulates our hydrogen through our system for us. We can do different things. We can pulse with it as well and control that to cycle pressure transducers. Our pressure transducers right now are from No Shock out of Berea, Ohio. Those are the black units right there.
Okay.
The other major components from Omega Engineering, we have thermocouples, just basic Chromega K thermocouples. We also have from H2 Scan a hydrogen sensor for measuring our hydrogen in our system. And up here we have from Viesela Technologies out of California, we have a humidity sensor. And that's what we're using to measure humidity of the system to calculate the mass of the hydrogen, because of right now we're using a Alicat Scientific mass flow controller to control our flow rate in our system. How we're controlling our system is we've got a compact Rio from National Instruments. It's a real-time controller, so we can either run it just from the computer, or we can have it run independently on its own just from the controller. So that's pretty much the. Oh,
and you've got this attached. It's got Ethernet. It looks like an Ethernet connector on it.
Right. We have a couple Ethernet cables running from all of our equipment. Our SMC manifold up here for pneumatic control of the bellows valves that are on our test stand for exhaust and for controlling our test bay. We also have. I'm trying to think here. The compact Rio has a network cable on it, and our power supplies are also controllable in LabVIEW through TCP/IP.
Oh, that's cool. And where's your controlling computer now?
Currently, it's down right now. We're having some issues with IP settings. But, right now,
this would be it right here?
Yeah. Right. This is our main control setup right now. As you can see, we have our gauge panel here. So we go through and we have our three gas process temperatures, our four major pressures in our system, and then our humidity. After that, we also have our pressure differential gauge panel, which is going to give us our difference in pressure from inlet to outlet of different components. From there, we have our two charts that we're graphing our data, and then this is all compiled out to a TDMS file for using the data later on. Oops, that's our. And our temperature chart and humidity. We're starting to get into automation right now. I just had something basic set up, just take off manual control, and it'll run on its own for a little bit.
So the objective here, if you had to, in one sentence, exactly what is this? What would you say this is doing? How would you explain it?
This is testing components to make sure that they will work for a specific purpose on a fuel cell system.
Okay. So you're measuring pressure, temperature, humidity. Are those the major variables?
Yes.
Yeah. Yeah. Interesting. And what would this apply to?
Well, for instance, Rolls-Royce is doing a 1 megawatt power plant, and getting used to the industry. This helps our students get used to the industry, so that they can be hired into a company like that, like Rolls-Royce or Contained Energy, both of which we have on our campus. But it'll allow them, if they wanted to put a component into this and test durability of the component. And this is all done under the Department of Energy as well, so we'll be doing testing in the upcoming months for them.
Excellent. Well, great. Thank you very much for your time, and congratulations on your awards this morning, your student awards, and enjoying DC.
Yes, definitely.
Oh, yeah.
Except for the traffic, but
Yeah. Did you drive here or did you fly?
we drove for 6 hours to get up here.
It's not a bad drive, but yeah, you got to do it at the right time for traffic, right?
Yes, it wasn't too bad. So.
Thanks a lot, you guys. Take care.